So in today's video we'll be covering regression lines. So regression lines. I'll be assuming that you have the basics of the regression lines covered. This video is entirely on the derivation of the regression lines. Especially for this video, I'll be taking the example of the first regression line, that is y on x. Okay, and in the next further videos, I'll be describing, also giving you the derivation for the second regression line, that is the x on y one. So let's just assume that the regression line is y is equal to a plus b x. Here, by the way, for this one, y is the okay. Let me just write it here. Y on x. Here, y is the study variable, and x is the auxiliary variable. Okay. So what we are actually doing here is that we have a bivariate data. Okay, so let's say the bivariate data is xi yi, where I varies from 1 to n. Okay, and we are trying to estimate a value of y based on x. So that's what we are doing. So we just assume this one to be our regression line, and now we will try to find out the value of the two constants a and b. Okay, so let's just say okay, let me just tell you one thing. So suppose this one is your y and this is x, and these are your various data points. Okay, and you plot by doing the analysis, you find the regression line of y on x to be something like this. Now obviously it has some errors. Okay, that's quite obvious. Now obviously we have to minimize those errors. So we have to minimize the error sum of squares, that is the various errors from this point, things like that. Okay, so this was just a small example of what we will be doing. So let's just say, so the error actually would be, so yi is the actual data, yi is the actual data point, and yi is the estimated data point. Okay, so let's just start with the derivation. So any error that will be formed, the error would be something like, so the error ei would be nothing but yi, that is the actual data point, minus the estimated data point. Okay, now what we want is, we want the error sum of squares, that we need the summation of this error squares. So what we want is, actually we want to find the error, and obviously we would try to minimize it to find the regression lines. So we'll define E as, we would do the summation of the ei squares, I is equal to 1 to n, which is nothing but summation I is equal to 1 to n yi minus capital Yi whole square, which is nothing but summation I is equal to 1 to n yi minus a minus b xi, just putting the value of y at this part. Okay, so we'll keep it for the time being 1. Now let's do one thing. we will be trying to minimize this sum of squares. Okay, error squares. So now now obviously for that reason what we'll be doing is we'll take the derivative, that is del E del A. Okay, and obviously to find the point this would be have to 0. So it would become summation I is equal to 1 to n 2 times yi minus a minus b xi, and obviously it will be, since we are doing it with respect to a, so it will come minus 1 is equal to 0. Okay, from here what do we get? We get summation I is equal to 1 to n yi minus a minus b xi is equal to 0. Okay, so since this 2 will be going to the 0 side, this minus 1 will go to the 0 sides, and they all will get cancelled. Okay, so we'll get this one. Let's just open the brackets. So it becomes summation I is equal to 1 to n yi minus summation I is equal to 1 to n times a constant. Okay, let me just write the step, minus b times summation I is equal to 1 to n xi equal to 0. Let's divide the entire thing by n. So 1 by n, 1 by n, and 1 by n. Okay. Now obviously this one is nothing but y bar. This one is nothing but b times x bar, and this is nothing but a constant. So this will give n times a, and this is 1 by n. So this term will give a only. Okay. So this becomes y bar, and this becomes minus 1 by n multiplied by n a, so which is nothing but a only. So I'll write it as a minus b times x bar equal to 0, which is nothing but y bar is equal to a plus b x bar. Okay, let's say this is equation number 2. Now let's do the same thing for b. So del E times del B equal to 0 implies summation I is equal to 1 to n, and if we go to this part, we are taking derivative of this. So if you take b, obviously derivative with respect to b, the x minus xi will come outside. Okay, so this one becomes 2 times yi minus a times minus b xi multiplied by minus xi equal to 0. So this will become, obviously 2 will be cancelled out because of the 0, and obviously same with the minus sign. And so it will, what will happen is like it will become summation I is equal to 1 to n multiplying xi inside the bracket minus a times xi minus b times xi squared equal to 0. This is nothing but, let's just open the bracket, summation I is equal to 1 to n xi yi minus a times summation I is equal to 1 to n xi minus b times summation I is equal to 1 to n xi square equal to 0. Okay, now similarly let's just divide the entire thing by n. So 1 by n, n by n. So it becomes, this becomes 1 by n summation xi yi I is equal to 1 to n. Let's just take the other terms on that side. So this would be nothing but a times x bar, and that would be nothing but plus b by n times summation I is equal to 1 to n xi square. So let's just say this is equation number 3. Okay, 2, 1, and 2, and 3. Now equation 2 and 3, these are called normal equations. let me just box them for you guys. This is one equation and this is another equation. Okay, so these are the two normal equations. Now let's just solve using the two. So using 2 and 3 we get, okay, now what we'll do is, in place of a, we'll write it as y bar minus b times x bar. So let's just copy this one down here. We just copy this entire thing down here. Copy, paste, erase the rest. Yeah. Now now y bar is equal to a plus b x bar. Therefore, a will be y bar minus b x bar. We'll put this thing. Let me just change the color of this so that you guys don't get confused. Let me just make it yellow. Okay. So this will be nothing but a times, sorry, not a, y bar minus b x bar times x bar plus b into 1 by n summation I is equal to 1 to n xi square. So x bar y bar minus b times x bar square plus b times 1 by n summation I is equal to 1 to n xi. So it becomes 1 by n summation I is equal to 1 to n xi yi. I hope you guys are able to know where this is going. So taking this term to the left hand side, we'll get minus x bar y bar, and rearranging towards the right, it becomes b times 1 by n summation I is equal to 1 to n xi square minus x bar square, which is nothing but, this implies covariance of x comma y is equal to b times, this is nothing but the variance of xi, so v of x. Okay, or you can also write it as b times sx square or sigma x square, anything. Okay, so b is nothing but covariance of xy by variance of x. You can also write it as, now if you guys are already familiar with the thing, this the covariance of xy can also be written in the form of r times sx and sy. There is standard deviation of x, standard deviation of y, and r is the correlation coefficient. And vx can be written as sx square. So this will be nothing but r times sy by sx. This thing is also known as byx, and it is called, let me just write it for you guys, regression coefficient of y on x. You can easily remember it in this way, since y on x, so y on x, y is on x, like that you can remember it. Okay, x is in the bottom, since x is y is on x, so x is in the bottom, you can remember it in this way. So a becomes, so a is y bar minus bx bar, which becomes nothing but y bar minus r sy by sx times x bar. Okay, So our regression line, which is nothing but y is equal to a plus bx, becomes a is nothing but y bar minus r times sy by sx times x bar plus bx is nothing but r times sy by sx times x. So if you just rearrange the entire thing, therefore y becomes y bar plus r times sy by sx x minus x bar. So this could be also be written in the form of y bar plus byx times x minus x bar. So this is the final result. Okay, so this regression line of y on x, so y on x is used to estimate the average value of y for a given value of x. Okay, so in the next video I'll be doing the derivation of the second regression line, that is the regression line of x on y. If you like this video, do give it a thumbs up and share and subscribe to my channel. The notes of this entire video will be available on my Telegram channel, the link to which I'll be adding it in the description of this video. Thank you.